The simple act of looking at a photograph can transport us through time and space. The same thing happens to a much more dramatic extent when we look at the night sky.
When you think about it for a minute, we're time travelers.
Oh yes, you Hercules.
Michael Castellas helps oversee the Astronomical Photographic Data Archive, or APDA, at the Pisgah Astronomical Research Institute in western North Carolina.
Today, when I look at a star, I'm traveling back in time because I see the star the way it was. But we're also time travelers in APDA because I can never go back in time and take an image of the sky the way my colleague astronomers did 30, 50, 100 years ago.
Since the archive's inception in 2006, Castellas has played a vital role in curating one of the most comprehensive collections of historic astronomical photographs in the world. The archive is housed at a secure facility whose past is cloaked in mystery. The Pisgah Astronomical Research Institute, or PARI, as it's better known in the astronomy community, is a 200-acre research campus in the rolling hills about 45 miles south of Asheville, North Carolina. NASA constructed the site in the 1960s as the Rossman Satellite Tracking Station, a sprawling network of buildings and scopes built to monitor manned and unmanned space missions. But by the 1980s, the federal government transferred the property to the Department of Defense, who reportedly used the facility to eavesdrop on foreign communications. After the Cold War, the facility was decommissioned and reborn as a not-for-profit foundation dedicated to astronomical education and research.
One of our missions is to capture collections that might otherwise be lost.
PARI invites students and professionals of all ages to use the facility to advance their understanding of the great beyond.
Up until the early 1900s, our universe consisted of the Milky Way galaxy, our 100 billion stars, and these little nebulae. Well, with photographic plates, astronomers could record those nebulae, bring them into a lab, and measure their brightnesses. The whole universe just expanded dramatically and became a completely different place, and all that because of the photographic plate.
When PARI scientists learned that hundreds of thousands of old astrophotographic plates were in danger of being thrown away, they launched the Astronomical Photographic Data Archive.
We do get some scientists, and I'm a little surprised by this, who say, well, why would you want to keep those old plates? And at one conference, in response to that, a colleague of mine pulled out a photographic plate. He said, this is the only plate in existence of this particular object. And he put it down on the table in front of him and took a hammer and went, there. And people, what did you just do? You know, and so it was a shock. And it was a sort of thing that started to wake up other parts of the community and say, well, maybe we really need to do something with this.
APDA currently houses nearly 150,000 photographic plates and film, each a unique record documenting a specific time and place in space.
Well, what we're trying to do is preserve the history of optical astronomy.
APDA Director Thurburn Barker is a lifelong amateur astronomer who helps survey the moon for likely landing spots for the historic Apollo missions.
Since the 1980s, most optical photography through telescopes is being done with charge-coupled devices, digital cameras. And because of that, the archives that have been at institutions, observatories, universities since the late 1880s has been relegated to storage in, let's put it this way, not very environmentally sound storage areas.
From the mid-1800s to the early 1990s, astronomers used the art of photographic emulsion to capture images of celestial bodies. Those images were often recorded on silver emulsion and etched onto glass plates.
This is my favorite plate for several reasons. One is the large area coverage. Secondly, it has a very famous star in it, Eta Carina. It has blown out 2 large knots of gases, which are visible with the Hubble Space Telescope.
Photographic emulsion allowed astronomers to document the night sky with unprecedented accuracy. But the focus of their research was not nearly as wide as their field of view.
When astronomers took photographic plates, they would use telescopes that would look at a chunk of the sky that would be typically 5 degrees by 5 degrees. Now, to give you perspective, when you look at a full moon, it's a half a degree across. And when astronomers did that, they were interested maybe in 1 or 2 objects in that field of view. And then they put the plate away, they finished their study, put the plate away. Well, I'm sorry, but on 5 degrees by 5 degrees of the sky, there's hundreds of objects. Just hundreds of them that nobody has ever looked at before. And that's what really piques my interest as an astronomer, is that I pull out any one of those plates and I'm going to find something interesting, something that nobody's ever seen before.
I don't know what that is.
Castellaz jumped at the opportunity to discover the hidden secrets inscribed in the photographic plates. He began with a series donated by the University of Michigan astronomer Nancy Hawk, which was part of a collection taken in Chile between 1967 and 1984.
I pulled out one of Nancy's plates and I said, I'm going to look at all the other stars on one of her photographic plates. In fact, I'm going to go through all 3,000 of her plates. Well, an hour later, I said, I'm not going to do this. This is insane. How can I possibly look at 3,000 plates with hundreds of stars per plate to figure out what's there? I thought for a minute. I said, you know, there's 7 billion people in this world. I'm going to let them do it. And that was the birth of SCOPE, the Stellar Classification Online, public exploration.
It is a citizen science project aiming to classify, in some cases, stars that have never been examined by astronomers before.
Education Director Christy Whitworth has guided the SCOPE project into a dynamic crowdsourcing website.
With SCOPE, 2 of the major pushes are to make this data accessible to students, to teachers, but also to the scientific community that are interested in these spectra. Then the second part is to gather as many voices as we can to say this is the right classification.
SCOPE invites anyone with an internet connection to help classify stars in the collection by identifying the stellar spectra. Each star has a unique spectrum or mix of light coming from it. Similar to a barcode, it is used to determine the star's temperature, composition, and distance.
If everybody on Earth does 1 star, we might be done in a year.
In central North Carolina, 7th grader Ruby Baird is doing her part to help identify APDA's vast collection of stars.
It actually is really fun because it's scientific stuff, but you don't have to be at school to do this. You don't have to be like at a museum to do this. You can just be at your house on your laptop.
Ruby says SCOPE has piqued her interest in science and astronomy.
I haven't showed any of my friends this yet, but I'm sure they would be totally interested in this. They'd be amazed by how easy and fun it is. Like, I think they'd think it was really cool.
For the past 150 years, photographic plates have captured the imagination of citizen scientists, in addition to more well-known scientists.
Einstein predicted that a star that's next to the sun, its starlight is actually bent around the sun. During a solar eclipse, the moon has passed in front of the sun, the sky goes dark, you can see stars. And what you can do is you can image the night sky where those stars are before the sun is there, then wait for the solar eclipse to occur, and then you look at the positions of those stars. And Einstein predicted that those stars would not be in the same place because their starlight was bent. So photographic plates were used in this really critical experiment, and showing relativity was correct.
Castellaz believes the APDA collection holds similar potential, waiting for future scientists to unlock the mysteries of the universe.
I think we've made great leaps and bounds in our understanding of cosmology, planets around other stars, nebulae, the composition of space, composition of our atmosphere. But it all starts with a true record of everything we see. And if we throw this stuff away, the opportunities of exploring this world around us go with them. And we just can't I can't let that happen.